welcome back. We're going to get into answering some questions that you might find in a test or a textbook, or you might even find them in an exam. It's important that we learn to apply all the main points on both electromagnetism and electromagnetic induction. So let's go and have a look at some examples that we've got here. So here, first of all, in this question, we've got the diagram shows a coil that's connected to a power supply. And the power supply is indicated by that positive terminal and that negative terminal. We recognize that the wire is wrapped around an insulator, and now we're going to see exactly what the questions are. So it says, indicate the direction of current through the coil. Now, that is really not difficult, but it's an important point to make, that whenever we are asked for the direction of current, we are dealing with conventional current. It's the direction a positive charge would move in a circuit or in a field. And so in this case, we recognize a positive charge would move from the positive terminal of a battery or power supply to the negative. And so we can simply recognize here that the direction of current is from positive. It's going to go up behind that coil, and it's going to come down on this side, and it's going to come down on this side, and it's going to come down on this side and come out at the negative. So there's the direction of current. Very easy to be able to work it, but you must make sure that you remember what conventional current is. Next question. It says, determine the north pole of the coil. So let me just quickly put those arrows in again and recognize that the current is in that direction, and we have to use one of the two laws or two rules to find the direction of the north pole. Now, in a solenoid, a coil, it's easiest to use the right-hand solenoid rule. Remember, we're asking for the pole. So there's one pole. So we're going to use the thumb for the pole, and we're going to use the many fingers to show the direction of the current. And so on this side, we recognize that the current is going up over there, it's going up at the back, and it's coming round on this side, over the front, and you can see my fingers are curled down over here, pointing downwards, just like those red arrows would be, and that tells me very clearly that the north pole will be over here, and the south pole will be over here. So that wasn't too difficult. Just need to remember to use the right-hand solenoid rule. Now, if by any chance you forget the right-hand solenoid rule, well, then it's really not too difficult either. We just need to remember the right-hand rule. Let me show you what I mean. And what I would do is I'd recognize the right-hand rule shows me the direction of the current. It tells me the current is going up. The field lines are going into the board at that point. So if I were to mark these field lines, I'd say they're going in at that point, around here. And that means that on this side, where the wire is coming down, the field lines are coming out. So if you look, there it's going down, one piece of wire, the field lines are coming out. So if I were to look at that end of that coil, what I'm recognizing here, I'm just looking at the other view, and I recognize that the lines were, the wire was going up over there, the direction of the current was going up, and I've already said when it's going up over there like that, the field lines, the magnetic field lines, are going into the board on this side, and they'd be coming out on this side. Now, as I move this red line around a little, and I'm going to just make sure I've got the red line moving around, and it's like that. On this side, it's moving down, And what I recognize here, using my right-hand rule, then you'd see that the field lines are going, the current is going down, the field lines are going in on that side. So outside of this piece of wire, I've got little crosses. They're going in on that side. What would they be doing on the inside of the coil? Well, that's not too difficult. They'd be coming out on the inside of the coil. So that means there'd have to be dots on the inside of the coil. And if I'm looking at that end of the bar magnet, of the coil, it's like a bar magnet. And where do we see field lines coming out? We see field lines coming out at the North Pole. So you can double check yourself. Just use the right-hand rule. But of course you need to practice it to make sure that you've got that right. So let's go to the next question. The next question says, draw a diagram to show the magnetic field around the coil. So I'm going to just simply redraw the coil for a minute so that I've got all the details right. I recognize that end is the north end, that end is the south end. I'm going to just put the pieces of wire on and say in which direction the current was going. So we've got that clear as well, and we recognize the current was going down like that. And at the back here, the current was coming up, and at this end, the current was looping over, and if I'm not mistaken, there was one that was coming straight down like that. So where this is positive, this is negative. Now, let's see what the magnetic field, because that's what we're asking. We're wanting the magnetic field around the coil. Now, the magnetic field lies in 3 dimensions, but it's much easier if we just draw it as a flat plane, okay? Because it's in the same plane as the wires as well as the coil. So we're going to draw that, and I'm going to just choose a slightly different color here and make sure that we've got those field line patterns being out at the North Pole and in at the south. So they're going to come in at the south and they're coming out at the North Pole. Right. I think we've covered that question, which was quite an interesting question, and it's important that we recognize this phenomenon of electromagnetism. Let's have a look at the next question. So here is a situation which says we've got a diagram below that shows a coil and a magnet with a pole P. So there's the magnet, and it has a pole P. A magnetic field is induced in the coil due to the motion of the magnet. So the magnet is moving relative to the coil, and we're needing to find out some things about it. Let's have a look. The first thing it tells us, determine the pole and direction of P if X is a north pole. So if X is a north pole, then what are the ways that P must be moving for it to be, for X to be a north pole? Well, quite simply, we recognize, first thing, if P was moving towards the coil, then it would clearly be a north pole. Because according to Lenz's law, we recognize they would repel each other. So as the magnet moves in, it would be repelling each other. Now, there is an alternative. We would also recognize that that might not be the only thing that could happen. We'd recognize that if P was moving in the opposite direction, in other words, P was moving away, then what would make that a north pole? Well, if it was a north pole, then they'd be repelling. No, that wouldn't be the case. This would have to be a south pole, because the whole principle is to undo or to prevent the change of magnetic flux. So a retreating south pole would be drawn back It wouldn't allow it to create as much change in magnetic flux. Next question. Now, what's the direction of the current through the coil? Let's make sure that we understand. North is in that direction. Let's make this one north and let's make it moving in. Now, if that's the North Pole, then I'm going to need to use the right-hand solenoid rule to be able to show the North Pole at that position. And from that, I'll be able to tell the direction of the current. So if I know North Pole is there, I'm going to use the curl of my fingers to say North Pole is there, then the current has to be coming down on this side. It's going to be going up on the dotted lines, and in that way, I will recognize that this piece of wire is connected to the positive end, and this piece of wire that comes out here is connected to the negative end, and we recognize we've got the direction of the current. That brings us to have another look at our concept map of this whole topic of electromagnetism. Remember the important bits, that there are two processes. Electric current produces magnetic field. A change in magnetic field when it's linked to a coil will create an electric current if it's a closed loop. So please remember those two aspects. Practice the rules, the right-hand rule, remember the laws, Faraday's law, and do lots of practice. I hope this has helped you. From me, we'll see you again soon. Bye.